Hi guys, today we're going to sort of finish all the polymers. If you look at it here, we have finished the first part here, which is the structure and properties of polymers. Okay, we done addition, we done condensation, right? We have also done we also finished proteins, right? Primary, secondary, tertiary, and even quaternary, right? So today I want to focus on part C here. Explain the significance, the keyword is significance, the importance of hydrogen bonding in the pairing of bases in DNA in relation to replication of genetic information. The first thing, of course, we need to know is something called DNA. Okay, what is DNA? Second thing we need to know is what are the bases in DNA too. Okay, thirdly is, well, about the pairing of DNA. Fourthly is, of course, hydrogen bonding. Fifthly is, why is it important for hydrogen bonding? Why not covalent bonding? Why not van der Waals forces? Why not ionic bonding? Because this can happen in proteins. And of course, in all these things, it's because of replication. What does it mean by replication of genetic material? We won't do the actual stuff. We used to have this in the old syllabus, but now they just want you to understand the importance, explain the significance of hydrogen bonding in the pairing of bases in DNA. After that, we will go into this part here. Okay, side chains. Okay, in polymers. I will talk about cross-linking here. Cross-linking. I'll give you two examples. I hope you can finish in time. Okay, cross-linking. We're going to do one polyester. All right, one polyester linkage. Polyester linkage or ester linkage. I should put it poly. That one is, of course, vulcanization, sulfur linkages. Okay, so I prepared these two with a question. And of course, lastly, which I want to finish off today with this part here, organic synthesis. Now there are two parts here, right? The first part here, I cannot do it online because we will use a book. We use our textbook. Okay, so I will do it in class. Synthetic roots is a summary of all the function groups you learn. They put it all into one. All these are into a question. Ask you to use the reactions of all these functional groups, okay, to predict properties of the substances. And multi-stage synthetic roots, okay, all this means they all talk about one. They all come in one question. That means you see the whole picture. I also do this when I do in class with you. But I want you to see two questions, very difficult questions. Not so difficult. It's difficult in regular exams, okay? I have planned two questions already, okay? So let's first start with DNA, right? Here you can see here, okay? I'm going to talk about, explain this one here, okay? Explain the significance of hydrogen bonding in the pairing of bases in DNA in relation to the replication of genetic material or information. Now, what does it mean by a DNA? Those of you who have done, if you have done biology, you will be way ahead of everybody, okay? So you don't have, never mind. We will see what is it here, okay? Page 7. Just a bit over here. This notes are from everywhere, okay? So just thank you whoever that made it, okay? I would, now, you can see here, DNA is actually, we all have DNA, the DNA is when our father and mother, come together and, well, sperm and egg get together, and all the material that your father has, your mother has, right, are joined together, right, to form an ovum. And inside this cell there, okay, it is all this information stored inside. They give like why your eyes is black, your eye is blue, or your hair is black, whatever. Okay, now remember here. Sorry. Now DNA is basically like this. Okay, DNA consists of two strands. Now this is called a strand. Okay, here. Okay, I'm going to draw this strand. One strand here. Okay, it's a long strand that continues to go on and go on. And another strand here. Two strands. Okay, long strand here. And there are two strands, they are intertwined into a helical. I'll show you a helical shape. They actually ask you what it means, no? Okay, I'll just show you first, okay? So you can see here, that means they intertwine, okay, that's it, right? So you can see here, two strands, right? Okay, one strand here, going here, and going down, okay? Going down here. And the other actually from down moving up one, okay? Down moving up here, moving up there. Okay. How come they're intertwined? Well, because of they're joined together, right? This part here, they're joined by this now. These are hydrogen bonds here. Okay, why hydrogen bonds? Because now they're strong enough to hold them together, but weak enough to be broken, okay, under normal temperature by some enzymes, okay, right? And then hormones, okay, here. Now, so what do this whole thing consist of? Now let's look at it, okay? So now the DNA, the two strands are made of three things. You see here, okay? Structure, right? So what is DNA? It's called deoxy. That means don't have deoxyribonucleic acid, okay? Right? Ribo means it's a sugar, right? Which means I can see down here, right? It contains a this is called a nucleotide. So this is like a monomer, okay? Okay, this is your nucleotide. Nucleotide, must understand. Nucleotide. It consists of a phosphorus. This is a phosphorus molecule, Pt4 actually. This one interesting. Later you see that this OH here, under acidic conditions, alkali conditions, the H will come up. Okay, and get minus here, so you get 2 minus here, which is very important when you do your DNA fingerprinting. Now about that. Now this is a phosphorus molecule, okay? The phosphorus molecule, actually it's the OH here at first, and it's joined to now this part here is called a ribose sugar. Ribose sugar. But it's called deoxy. Now there are two types. One is oxyribose sugar, one is deoxyribose sugar. I'll show you here, okay, the two types of sugar now, okay. Now in RNA is the other type of things in our body, almost the same as DNA, but it comes in a different base. Now mind, okay. Now RNA is ribose nucleic acid, okay, ribose nucleic acid. Okay, right? Now, here you have got, see, everything is the same. This is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. This is called a 5 prime. Okay, and this one here will later bond with the phosphorus here, right? And this carbon 1, the OH here, will bond with the base after I show you, okay? So now here you can see that this is the thing which is different from RNA and DNA. This one got oxygen, got OH here, O here. Here you don't have, so you got deoxy. That means no more. I debone you, that means I take all your bones, okay? Deoxyribose sugar here, okay? So now this is the sugar part. So of course, there is what is this? Right? So you can see here. All right, now the bases, there are 4 types of bases. You can see here, adenine, represented by A, guanine by G, thymine by T, cytosine by C. Now what are they? I'll show you here. All these are for a reading part. I just want to importance of the significance of hydrogen bonding. Okay, now see, all right? This diagram comes out a lot in exams. I just want to show you here first. The things here. All this can read up by yourself. All right. This is from they used to give us all this. What is this? These notes from there. From Cambridge. Okay. Sorry, a bit slow here. That show the 4 types of base, okay? Here we are, right? Never mind, I show you the other one better. Okay, now basically here, you see, thymine is a 5, is 1 ring. Okay, this is the ring here. Remember that now this is a phosphate. This is your the oxyribose sugar. Right now, this is a phosphate here. This is a deoxyribose sugar, and this is a thymine. Okay, T for thymine. Okay, THY thymine. Okay, now this again. Now see, so move this way. So move this way. Okay, so your phosphate is over here. The oxyribose sugar is here. And now here is A, adenine. Adenine. I think a tiny got E here. Alright? So adenine is a 2 ring. 1 ring here and 2 ring here. Okay? So they always bond. T is always with A. And G, guanine, always bond with cytosine. Cytosine. Okay? Right? Now here, you can see here, right? Guanine is 2 rings. 1, 2. The same type as adenine. Same type here. Cytosine is a 1 ring. Okay? And so there are nitrogen here with a hydrogen. Okay? And nitrogen here is free here and a lone pair here. Of course, here for what? Hydrogen bond here, hydrogen bonds. The oxygen here got lone pairs, isn't it? Okay? The H to the N here, of course, this can form what? Hydrogen bonds. So there are 2. Here got 2 hydrogen bonds. Must hold 2. T for 2. Okay, remember 2 hydrogen bonds. Okay, now, right? So they are strong enough to hold them together in a helical 2 spiral called anti-parallel spiral. Okay, and they are strong enough to hold them together, but weak enough for you to break in room temperature with some of this polymerase and some of these enzymes. Okay, for it to multiply the cells. Okay, to replicate, to produce more DNA. Here, same thing here. The nitrogen is with hydrogen here, of course, and then the oxygen here from hydrogen bonds now. Okay, same thing here. Hydrogen here with nitrogen here can with nitrogen here, and here oxygen with the hydrogen here actually. So it's like got 3 bonds. So G and C got 3 hydrogen bonds. Okay, right? So the distance between them is the same now. That's why they found I think it's fantastic. Huh? It's the same, that's why they have got same shape. Okay, right throughout the double helix, we call it. Right? So you can see here, okay, now there's 2 strands. So they call it one strand is 5, see, 5 prime to 3. Why 5 prime to 3? Because it starts with 5. So now, I put another color. Okay, see here. 5. 5 is it? Why 5? 5. Carbon number 5. Okay, 5 to 3. Here's 3. 1, see, it's 1, 2, 3. This is 3. Okay, that means the polymer go from this side onwards. The other strand is 3, right? 3 to 5. Here, now this is 3 here. Okay, now there is 3 here. The last one is 3 here. Right? 3 here. So 1, okay, 3 here. Yeah, 3 here. Okay, so this chain. 3, okay, 3 to 5. So we talk about this one. Actually, it's going this way. Okay, right? So now this, so that means this is one nucleotide. Okay, this is 1 nucleotide. So all these nucleotides are bound together in this chain. This chain down here is called the phosphate sugar chain. Okay, got 2 chains here. This is called the phosphate sugar chain. Phosphate sugar or ribose, okay, chain, okay, and they're linked together, right, with the bases, right, the pairing of the bases, A to T or T to A, G to C or C to D by hydrogen bonds, and this form a long chain. You can see down here, long chain of polymeric chain, right? Strand here. Okay, now you can read out all this by yourself, just for addition, okay? Long chain here. Okay, right? Anti-parallels, okay? Like this. So now this diagram is come out a lot, right? So remember, they don't care. Of course, this one you can see it goes from here to here, then go from here to here. Okay, they run anti-parallelly, right? So remember the C to G, three hydrogen bonds. Okay, right? A to T, here got 2 hydrogen bonds. Okay, right? So now this is your structure of DNA. All right. Now remember, here you can see that why. See, so now these are all in detail. You can get from the website. Get out. So this is hydrogen bond here, hydrogen bond. Okay, right? Now they will unravel. The keyword is called unraveling. Okay, unraveling means that they will break up. Okay, now here there are more examples here. See, what's the function of DNA? It's a repository. That means to deposit. Okay, repository, a place to keep safe genetic material. That means you are Chinese, Indian, or Malay, or European. All these things is kept here. So it's called a genetic code to produce your proteins, basically. Okay, so it will self-reproduce. It doesn't need another thing. So how does it reproduce? It will unravel. It will break up. What will break up? The hydrogen bonds will break into 2 strands. Now see here, okay. So now this is the original. This is the original DNA. Okay. Then you break up here. Break up. Okay. So now they form 2 strands. 1 strand here. 1 strand here. See now. Right. And then the RNA will bring in the other part here and fill up here. See now. Fill up here. And then from 1 strand you get 2 strands. Same. 2 strands like that. Okay now, so 1 becomes 2, 2 becomes 4, 4 becomes 8, 8 becomes 16, and then 32, and keep on multiplying very fast. That's why cancer is like this. Cancer will cause itself to multiply like crazy. Okay, right? So this is called replicating. Why does replicate? Because the hydrogen bonds. Why replicate? Well, why replicate? To reproduce itself. Okay, to grow. Okay, to grow, right? From the cells to grow. And now how can it replicate? Because breaking of what? Breaking of hydrogen bonds. So what is the significance of the hydrogen bonds? For it to break hydrogen bonds. Okay? By what? By unraveling. Unraveling. Now these are all important terms, okay? Right? So to reproduce, okay, to replicate, to reproduce more of itself, okay? So this is how the thing happens, okay, here. Now, triplet coordinates we don't need to know anymore, okay? It's no longer in the syllabus. Now let's look at some of the questions that come out, okay? I want to quickly finish this, okay? Now let's look at page, page 23. 23 here. Simple questions come up very simply one. Okay. 1. Describe the meaning of a double helix. Right? Double helix. What does it mean by double helix? Okay. Right? Okay. Remember, double helix means what? Double means 2, isn't it? Like that. Okay. Okay. So the answer is 2 interlinked spirals. So you must learn to explain yourself properly. 2 double helix interlinked. It means they're linked together. By what? By hydrogen bonds, okay? Okay? 2 interlinked spirals or 2 interlinked chains or strands woven around each other. Okay? Right? So the answer is, they ask you like this. How is this? the strands of a double helix held together? Hydrogen bonds in. Remember, it's hydrogen bonds, huh? Right? Remember, on the main strand, let's say got now this one strand again. This is a phosphate. This is a sugar. And here is your base. Go to phosphate, sugar, and base. Okay? So this one strand. This phosphate is a sugar, or ribose sugar, and this is a base. And then goes to phosphate, sugar, and then base. Yeah. So this is like a backbone. And this one chain. The other chain is here. Okay. So these two chains are linked together by what? By hydrogen bonds in between the bases. Okay. So how are the strands in the double helix held together? Very simple. By hydrogen bonds. Between the bases, you must say is between the bases. Okay, two words here are important in the marking scheme. Is hydrogen bonds. So this hydrogen bonds between the bases. What are the bases? There are 4 types. The adenine with your thymine. How many hydrogen bonds are there? 2. Your guanine with your cytosine. How many hydrogen bonds are there? There are 3. Okay, now very simple, isn't it? Right? So now remember here, okay, they'll ask you very simple questions because it's chemistry, it's not biology, okay? Now, okay, 24, another simple one is this, all right? They ask you to draw. Okay, all this we have before. This one, this is a favorite diagram. This, as I said, because the diagram is actually from the Cambridge notes, okay? The diagram below shows a section of DNA identify the blocks X, Y, and Z. So X, of course, A here, A is what? It's a base, it's an adenine, adenine. What is this? T, thymine, has to be T, right? Thymine, T-Y-M-I-N-E. So X is what? Your ribose sugar. Sorry, the oxy. Forgot the oxy ribose sugar, right? And what's your wire? The phosphate. That's all you need to do. Okay. So this is how you identify the things here. Simple as it, right? No problem, man. Okay. Now these are questions. Another one here. The diagram shows one strand of DNA. Here, okay. Now this one strand there. Okay, let's say it's 5 here, 5 prime here, right? Okay, 4 here. This is 1, 2, 3, 4. Sorry, I have 5 here. 1. Okay, what am I doing? Okay, here's 3. Okay, now draw here. Of course, here you draw the base first. Okay, the base first. The base first. Easier to work backwards. A to what? T to what? To A, adenine, isn't it? A to what? To T, isn't it? Thymine. G to what? To C to what? C to guanine, isn't it? Then you draw, copy the same thing here. Then of course you draw the sugar, the pentose sugar. Okay now, right? And draw the line like that. See now? Easy, isn't it? Copy a thing there, that's all. Yeah? Yeah. Okay, don't be an artist, just simple one will do. Okay, just continue. Make sure you pair all of them. Okay. Down here. Okay, go on, is it? Right? So it says here, draw the complementary strand, labeling the bonds A to the original man here. A to T, how many hydrogen bond? 2 here. Hydrogen bond. Okay? Here 2 also. Just not enough. Okay, how many? 3. 3 lah. Hydrogen bonds. Okay, right? Labeling the components, okay? So you must draw, labeling the bonds, label number 1, the bonds, okay? Form 2, label what? The components, okay? AT and G so forth on the strand you draw. Cannot. Easy, isn't it? Not so difficult. 3 marks, man. Okay? But there are more of these. Let me just show you quickly going through them. Half an hour gone already. I want to go on to the other one, which is quite exciting actually. This is all book work. Okay? 25, 26 also got. Quickly. I'll show you. This is quite good. Now, you see, cancer is being, because see, cancer is growing on tumors, the big fella, you know, enlarged liver or enlarged whatever, you know, the thing grow extra big, so you get a big size growth there. Okay, so they want to find how to stop. Now, when cells grow, they multiply. That means the DNA is replicating, is it? So how to stop the replicating? You stop the unraveling. If it unravels, you stop it from base pairing, you know, too big to make more cells. So here you see, in recent years, a great deal of research has been carried out to finding different anti-cancer drugs. Tumors, which are often symptoms of cancer, are produced when cells replicate. They say means that they divide uncontrollably, right? So this in turn brought about by replication of the DNA. So it starts with the DNA. So how to prevent it from replicating? You go back verse 1, how to prevent it from unraveling? If it unravels, how to prevent base pairing? Okay, that means another base come to make the two individual, another two DNA. The two anti-cancer agents are methchloroamine and cystatin. Cystatin is quite common later you'll find in your chemistry. Okay, they work in binding the DNA and prevent replication. Okay, okay. So how do you do it? Now remember, first of course is a dichloro. I'm gonna use pen. Dichloro. Okay, chloromethylamine. Okay. Now here, don't care. Okay. Now here is the lone pair here. So what it does is it will stretch itself, the chlorine here, to form dative bonds, form covalent dative bonds, covalent bonds, which are very strong. They form between the two here. So the chlorine here will form here, right? So if the cell, if this want to break up to replicate, it cannot open. So it prevent it from unraveling. Okay, so this is one way. The other way is that cystatin here, again with chlorine here, okay? Again, right, the chlorine here will bond to the guanine. See here, bond here, okay? So even though it replicate here, it will block this space, this part here from bases coming in to replicate. See now, you'll block it. Okay, so this is how this anti-cancer drugs work. So now the question asked is, what type of bonding attach both the anti-cancer agents to DNA? What bonds? Ionic, covalent, van der Waals forces, hydrogen bonds. What kind of bonds? Okay, let's see from here. Okay, first one is of course covalent. Both are covalent, okay? Right? Covalent, right? So first one, of course, is chloromethylamine binds the two chains together, prevents unraveling. It bind the chain together, prevents unraveling. Keyword is very important. So the two chains cannot open. See the bonds, 5 marks, 1 mark for its dative bond, 1 mark for binding the two chains together. It means they want to open it, they want to break the bond, the hydrogen bond here. And then they bind here, cannot break, and it cannot open, close together. Okay, girlfriend and boyfriend fight. You go there and hold them together, cannot break. Okay, prevents unraveling. The cystatin will bond the two G's. Okay, the two G's in one base chain. Okay, bond them together, so prevent them from base pairing. That means even though they open, they cannot form new cells. Therefore, they cannot multiply. The tumor will die. No more tumors. Okay, so you can see from here how they ask the question. It's not a very biological question. They are all very chemistry questions. Okay, right? So just how the answer here. Okay, these are different. I just give a few more. Okay, so all drawing one. Okay, diagram 28, 29. Okay, let's go 28, 29. Okay, so, no time. 28, 29 also got plenty. Yeah, right? You can see here, they ask you, diagram shows DNA, study the diagram, identify the blocks J, K, L, and so simple, isn't it? Easy, kacang putih. These are cytosine, C with G, isn't it? Guanine. You know, J is what? Your deoxyribose sugar. Okay. What is L? Your phosphate group. You know, easy, is it? What is M? Thymine. So simple. You know, okay, all of them same. Next one also same here. Okay, what stops this strand from separating? Hydrogen bonds. That's not correct. The 2 marks. Hydrogen bonds between what? The bases. Must put what stops these strands from separating or unraveling? Called unraveling. Learn a new word a day. Okay, unraveling. What stops it from opening up or opening up? Or splitting up. Okay, what is hydrogen bonds? Which one mark only? Between what? Between the bases. They call it bases. Okay, what are the bases? Adenine, thymine, guanine, and cytosine. 2 marks, 1 mark for each of them. Is that clear? Right? Another one, page 29 also got draw again. I got all these things planned out for you, see? Okay? See now, see here. Okay, what types of compound are linked together? So 3 types, so simple, linked together in DNA. What are they? The phosphate, phosphate, what? The deoxyribose sugar. What else? Your base. You can put base here. You want to show off a bit. You can put all the base like A, T, whatever, and guanine and cytosine. DNA consists 2 strands linked together. Draw the block diagram. Illustrate this, showing 2 repeat units in each. The backbone. The backbone means what? Phosphate sugars. So you draw a phosphate into what? To what? Your sugars. You can draw blocks or whatever. Okay. And then here phosphate. 2 repeat units. 2. 1, 2. This phosphate. Sugar. Phosphate. Sugar. So for 2 enough, isn't it? 1, 2. Of course, the other one same here. Now remember, here to what? To another block. Here's what? Now you put A here. Okay? Here put G whatever put longer here. Okay now. Okay, guanine. So here to T, is it? T be longer here. Okay, whatever 2. Right? And this is your thymine. Okay. 3. And then draw, of course, your ribose sugar. You can draw blocks, whatever, okay? Don't have to be very accurate here, okay? Right? This is a T, this is a C, I, R, okay, do your phosphate here. Okay? Sorry, this is wrong here. Okay, okay now. Alright, phosphate here. Gonna finish it fast. Okay? So this is say draw again. So you need to be expert in the drawing of these things here. Okay now? Alright? Another one here. All this can do by yourself. It continues here. All this here. Okay? See? Again, DNA consists of a double helix formed by 2 strands held by hydrogen bonds. Sketch a diagram showing 2 base pairs. Blocks, components. Okay? 2 base pairs means AT and adenine and thymine, guanine, and cytosine. Okay? Right? Now here suggest what the effect of DNA replication would here, quite interesting here. Suggest what effect on DNA replication, that means to reproduce DNA and reproduce all the cells, would be if the hydrogen bonds between the strands were replaced by strong hydrogen bond. That means cannot open. You got to heat the filler very strong, high temperature, because covalent bonds are very strong. See, so you must boil your body like die like not. So the hydrogen bonds can be broken at room temperature just by some enzymes. They call it polymerase. Okay, all right. So they ask our questions for you to understand. Okay, I've got more questions here. Page 30, 33, and 34. All of them here. Okay. So I have finished your DNA. Okay. Now I want to go to this thing called about half an hour more. All right. Now organic synthesis. Now this is in part 1. This is part. This is let me see part. Now this actually this is organic chemistry part 2. No, okay. Right. You can see that my notes are part 2 now. Okay. I'm going to part 1 here. This our original the first part. Right. Now, as you can see that the question, they say, let me just, okay, I actually do too fast. Now, remember here, I tell you, you want to be fast, I forgot where those 3 pages. Never mind. Okay, see, go here. Okay, here I told you already the same one. Now this is part 2, part 2 of your notes. Okay. You see here, okay, right? Here, synthesis. Okay. Now remember, I'm going to bring the second part here. Synthetic roots. Okay, here. Later in class, I will summarize the whole thing. Okay, so here we're going to combine. See, for 1 or 2 or 3 organic molecule containing several functional groups. Okay, right? Identify the functional groups using reactions. Okay, the properties and reactions of these things here. Right? Multi-stage synthesis, you can see it, okay? Preparing organic molecules using the reaction. That means all the reactions now. Alkanes, alkenes, halogen alkanes, alcohols, acyl chlorides, amines, amides, aldehydes can all come together in one big picture. No, of course they use everything here and there, okay? Analyze given synthetic route, okay? In terms of type of reaction and for each step. Reagents, ask you what the reagents use and possible byproducts. Okay, I'm going to, because of time, I just go to a few of this. Okay, now remember here, I told you already. I'm going back. Now this is part 2 notes. Okay, chemistry part 2. Okay, here. Now this is part 1. I just show you one. Okay, show you one simple one first. Okay, not simple one. Okay, there are many here. Let's see. Okay, page 74. Let's go to 74. Simple one. Is that here? Okay. See the roots there. Some of this I think we did before. Okay. You can see here. Okay now. Right? Now this is our question. Okay, there. Right? See now, draw the structure formulae of the organic products for the foreign reactions in compound C. See now. Okay, right? So these are called synthetic roots. Okay, from here to here. Obviously, these are acyl chloride. Between here, of course, what happens? H come on, phenol in, and give you your esters in, right? So you form the ester there here. Okay, to carbonyl here to O to your phenol group. Simple thing. Right, to complete it, put plus your what? Now, of course, in any OH, make this Na plus, right? So actually, get here, right? NaCl. But it wouldn't be wrong. You just put HCl. Either this or this. Okay, they are interested in this only because organic product is here. They ask you for the organic product. See. Formula of the organic product. Okay. Now all this can try by yourself. I want to just dwell in 2 classic examples. Okay. All this here. Okay. Now the first classic example, which is well, not so very hard, but it's worthwhile attempting. Okay, 3, 2, 8. 3, 2, 8. Okay. Am I correct? Oh, sorry. Not 3, 2, 8. Sorry. See, I also hurry. 383. 383. Sorry, guys. 383. Okay. Is 384 on top here. It's very nice. It's like a puzzle. So you have to be sharp. You have to know your know your chemistry. If you mong cha cha, like gundu idiot. No, you don't know what your chemistry, but you will fail. I warn you first. You will fail. So you don't study, don't memorize, don't practice. Repeat, review. Your organic chemistry, you will fail. I'm going to show you why you will fail. Of course, now you should fail. You all should get A star. Fools. Although, question again. Although now remembered for his music, the Russian composer Alexander Borodin was a chemist. He is credited for the discovery of aldol reaction. We done before. Okay, it's called aldol condensation. Remember not? A product which is a compound J. J represents the following properties. So what is J? Okay, its molecular formula is this one here. That means, remember, you must remember this C. I'm going to write here because after I will draw a lot of things here. C4H8O2. So 4 and 8. That means there cannot be a ring, is it? No ring. Okay. So they say it's a neutral. Now there are 2 oxygens here. That means it cannot be what? Cannot be a carboxylic acid, not carboxylic acid. No, this one here. Elect. Don't have. Okay? It of course can be ester because ester neutral. Rest is sodium metal. Ester cannot make a sodium metal. That means that it must be a what with O, that must be must have OH now. Because with the O, if there's an O there, it can be alcohol, it can be carbonyl, which is a ketone, or aldehyde. Someone cannot spell. Okay? It can be an ester, right? It can be a amide, but of course cannot be because there's no nitrogen, so cannot be. So O here must be sodium some more, must be alcohol. Rest the phalanx wonderful, must be aldehyde. That means it must contain OH because aldehyde don't react with sodium one. No. That means here it will contain this one here, a carbonyl group and a H here. Does not react with aqueous bromine. That means no carbon not. Yes, not. Or no phenol. Anyway, cannot be phenol. Why? Because there's not. It must have a C6 not. No phenol. Right? It's not C4. Okay? So just the functional groups is a plural. Okay? Alcohol. The functional groups responsible for this. So first alcohol. COH. Okay, you can put this alcohol. Phalanx. Aldehyde. Or this one here. Must have a H here. Elect. Okay. Alright. So the result of bromine test show the functional group is absent. Identify the function easy. No alkene, is it? No carbon, double bond, carbon. Okay. In the 3 boxes below, draw possible. They say now straight change. My baby, no branch, okay? For J to fit the above. So here, of course, you would, trial and error. Now remember there are 3 only. Okay, now I'm going to draw here. Okay, now this is what you do, of course, put 3 here. Okay, remember there are, how many carbons are there? Guys? 4 carbons in. See here? C4H8O2 then. Okay, I put over here, C4H8O2. Okay, put down here. Okay, C4H8O2. So in exams, you're under pressure now, so you have to think fast. Fast, man! Otherwise you fail. Okay, 1, 2, 3, 4. Have to be, isn't it? Remember, it must have an aldehyde group, so must be at the end. Have to be. So there are 3 of them. Okay, actually I put here. Okay, put here. 1, 2, 3, 4. Okay, all of them must have this. 1, 2, 3, 4 must have this. 1, 2, 3, 4 must have this. That's not right. So there must be an alcohol group. Simple lah. That means it cannot branch not. It can be either can be here. Okay, the 2nd carbon or the 3rd carbon or the 4th carbon. Simple, you know, because this is carbon number 1, isn't it? Functional group, right? Okay, the rest of them is hydrogen. Now then count the number of hydrogens and carbons and oxygen, see whether it fits the molecular formula. Okay, now let's finish our result first. You must draw all the atoms there first. Okay. All right. This is quite simple. Okay. Oh, sorry. Okay, can't really simply put everything you want to put rubbish there. Okay, H here and of course H here and H here. It's common enough. 4 carbons, pass. How many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8. Pass. Oxygen? 1, 2. Pass. Okay, simple, isn't it? So they use all types of reaction to come up with that. Second one is a bit harder. Okay, let's go to the second one. This one is a really good question. You think like crazy. In exams, not many people can do it. That's why it will tell you the difference between an A star and an A student. So what are you? D star, is it? Fools. 3, 7, 3. Okay. Very nice question. 3, 7, 3, 7, 4. Okay, here we are. Okay, part B. Now, this one you really must think. Even I find it hard to do it. I mean, I say I'm not very clever, but I'm just very smart. So, 4 compounds. Where is it? Okay, 4 compounds E, F, G, and H are isomers. That means they have the same molecular formula, different structural formula of each other. Each compound contains an aromatic ring. That means it must have a ring. Okay. And each of them got 2 functional groups. 2 here. From the following list. First, it can be alcohol. It can be amide and H2. I say sorry. Hurry, and you get all wrong. Never mind. See, I'm looking at the time and I don't do this. Okay, so C. Yeah. Amine is your NH2. Carboxylic acid is C double bond O and OH. Ester is C double bond O, here's R and O and R dash. Phenol is ring and the OH attached to it. Okay. Right? 2 only. Ring and 2 more. Which of these functional groups can really, and cold, very important, the cold. It means cold means that it will react with a base, a strong base. Remember, hot, if it's hot, hot, it can hydrolyze your ester. Ester will dissolve your ester. Only hot. Cold cannot, tak boleh. Ester cannot. It means a strong base. So which of them here is a strong base? Of course, amine. All this won't dissolve. Won't dissolve. Amide, remember, is neutral. You must know, neutral. Right? This is neutral. This one, of course, this one is a base, it's not acid, isn't it? So this one is, of course, your amine. Which of these functional groups react really with cold? This, see again, cold. That means not ester, tak boleh ester. Which is alkali, which means it must be an acid here. So who is acidic here? Of course, a carboxylic acid. I better put blue color, okay? So when you revise, you know, okay? Acid. And of course, a phenol. So these 2 fellows here, okay? So here will be your carboxylic acid. And what? And phenol. Okay, now comes the summary. The molecular formula of the 4 isomers EFG, very important. Okay, this is the molecular formula. Write it big. Open your big fat eye. C8. H what? 9. Very hard to see, is it? NO2. All 4 carbons are insoluble in water. Okay. That means that it will dissolve in acid. It will dissolve in alkali. That means the function is reacting. So, solubility in HCl, E, so insoluble, soluble. Then which is soluble? That means this one is your amine. This is amine, isn't it? Okay, so this one not. So soluble in NaOH. Okay, now remember here, soluble in NaOH, of course, it can be 2. Can be a carboxylic acid, or your what? Or your phenol, isn't it? 2. Now here is where same. Okay, here same. It can be your carboxylic acid. So which is which? Or your phenol. Now you use your brain. You got any brains on? Huh? Okay, that's where you come in with the oxygen. Remember. Okay? Here. Amine. Right? Amine here, there is no oxygen now. Here. Right? Amine is just NH2. NH2. Okay? Right? Yes? That means here. That means here it can have 2 oxygen. It must have 2 oxygen. So it's right here. See now? 2 oxygen because it's 2 oxygen here. See now? Right? 1 nitrogen here. You see that? 2. That means here is because if it's phenol, it's only 1 oxygen. Remember, there are 2 functional groups here. 2 functional groups. One of them is here. The one must be the carboxylic acid. So here must be what? Carboxylic acid. So you see now, it's tricky, isn't it? Very good question. Excellent. Now here, all right? Which means here it's not an amine, all right? Okay, that means it can see that they're all different, okay? Which means that it must here soluble, which means it must be a phenol. If this is a phenol one O, that means here must be an amine. Anyway, here must be an amine as well. Amine. HCl is it, right? Insoluble is it? So it's amine. See now? Okay? Okay? Now look at the marking schemes. I think it is this one. No. Yes. Okay. Okay, see? See, you see why is the first functional group is either amine or amine? Because they all contains a nitrogen. You see that? It's either amine or an amine because what's the formula? See now, C got N. That means it's these fellas here are either an amine or an amine. It has to be. So if it's not an amine, it must be a what? Amine. See now, see that? So here, of course, got an O. See now, okay? So you can see down here, all right? So the first one, of course, you can see down the marking scheme here. Oh, no, sorry, this one. Okay, so see, alcohol, right? Carboxylic acid, I told you here, because the amine here got NH2. So there's NO2, remember? C, what is it? Yeah, keep on forgetting. Okay, see what? C8H9. NO2. C8, I say C8H9. Okay, so remember 1N, right? 1N. 2O must be from your carboxylic acid. Because the other O, the O must either come from the carboxylic acid or alcohol, okay? Or ester, is it? That's not. Okay? So now here, you can see here is carboxylic acid. Now here's your phenol. Okay, right? Now, of course, the other functional group here, okay, and here, for it to have 2. Here I must, this one here, I must have 2 oxygen, right? It must be an ester, okay? Yeah, okay, ester, right? Okay, because it cannot be the same. These two are different, cannot be the same. If you put it carboxylic acid, same again. Okay, so now how do you figure it out? How to draw it? Now I'm going to show you this. I think we are right on time. Okay, remember this one here? Now there are 4. I'm going to draw here. Watch, watch, don't blink. Okay, first draw the ring first. Okay, 1, 4 of them. 2, what time to do cross linking? Now mind, next time. Quite interesting, isn't it? 3 and 4. Okay? Now the first one we said, remember, the first one contains amide, isn't it? Okay, E, amide. So an amide must have here a C, double bond O, and your NH2. How many carbons on there? 8, isn't it? So it's 6, 7, one more, isn't it? 8. So one more here, can put anywhere. Carbon, okay, must contain alcohol, so put OH group here. H here now. See whether it fits into this formula or not. Count the carbon, 6 carbon here, 7, 8, isn't it? So 8 carbon. Now. One nitrogen, 1 nitrogen. 2 oxygen, 2 oxygen. Okay, hydrogen. There are 4 here. 1, 2, 3, and 4, 5, 6, 7, 9. Correct. So this is your E. Do you understand what I'm saying? Okay, now I'm going to put down a bit because I need the space. Okay, second one, F. F contains an amine. Okay, right? Now, let's draw the carboxylic acid first, okay? Contain carboxylic acid. That means it must be a carbon carboxylic here. Anyway, you can put up to you. Okay, now, amine. Remember how many carbons are there? There are 8, isn't it? So 6, 7, 8 here. Can put anywhere like carbon, and there must be an amine. So NH2 here. No oxygen here. H here. H here. Count again. 6 carbon, 7, 8. Correct. High oxygen 2. 1, 2. Correct. And 1. Okay. Hydrogen same. Here 4. 1, 2, 3, 4. 5, 6, 7, 8, 9. Now. Okay. Now, guys, you can also put a C here. It can also be, I'll draw here, okay. It can also be like that. You're not wrong because you can see the marking scheme, that up to you one. Here, a C, okay, right? And then an acid can, boleh juga, no problem. And then here is your NH2, also can. Okay. Now next, EFG. Okay, let's draw a bit more. Okay, G, amine. All right. Ester first better. Ester. All right. Remember C, double bond O, and then CH3. So you finish all the carbons, 6 already. Okay, and amine. I'll put here NH2 lah. Okay, work it out yourself. H. All right. Amide. Okay. Okay, amide. Phenol first. OH. Okay, so here got 6 already. 7. Okay, 7 and 8. So H2 here. Yeah. You put a CH3 up to you one. Okay, doesn't matter. O and then H2. See now, or you can put this one no, guys. Can one put an OH here. Right? Put a CH3 here. Same. Right? And put a C double one O here and NH2 here. Same. See? 6, 7, 8 is it? Right? Hydrogen is 3 here. 4 plus 4 here. So 4 plus 3 here. 1, 2, 3 now. No. Right? Okay? See? 4, 1, 4, 5, 6, 7 plus 2, 9, isn't it? Right? So you can see here, check the structure fits and blah, 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 blah. Now this is what you call a summary of everything. Easy or hard? Well, depends on whether you know your chemistry or not. And at the time when you do the thing, can you answer the question or not? And at the time, can you recollect all these facts and then work it out like solving a puzzle? No, like who killed so and so? No, Sherlock Holmes sort of thing. Okay, guys. Okay, now I finished all these things. I don't have time to go to cross-linking. Never mind. I will try to cover maybe one more lesson I thought can cover. See, I'm trying to hurry up. Never mind. I'll do it so that you understand. Now, remember, this is finishing already. No? Okay? I will do one more on the overall, just round out everything. Okay? But the polymer and the types of polymer and so forth, and the what is this? The organic synthesis with drugs. I'll do it in class. Okay? Now, right? I can't do it because the notes I use is from book. So after this, I plagiarize whatever I want to sue. Okay? So and then one more, right? And then I'm going to do the last one, of course, is NMR, nuclear manipulations, which comes out together with organic chemistry questions, together with infrared. Okay? So as we say, we have finished all these things here. Remember now this, you look at it carefully here, right here. This one here I will put in front here. Okay, this is from organic chemistry part 1. Okay, this is part 1. Okay, this is part 1. And the other one, this is organic chemistry part 2. Okay, your DNA one, right here. Let's see. Okay, so part 2 now. Okay, right. So some parts are overlapping now, but doesn't matter. I'm sure you got brains enough to see what is not. Okay, so I want to say goodbye. Okay, go. So goodbye. Please study, otherwise you will fail. Okay. Okay, stop recording. Bye bye.